Give me a sign.
Okay.
We start.
Good morning, everyone. Good morning. Marcus, we are live right now. So, well, welcome everyone in this room. Welcome to the today's session of STE. Thank you for joining us. I know that we are online, and there's some people also in the auditorium. And my part of the presentation will be principally run by my colleague, Markus Kick from Phoenix Contact, Germany. He's in the headquarters right now. And the idea of the presentation is to share with you our vision about what is the concept of digital factory. And we place on this name, one last name, which is now, which means that we can together give solutions to the industry to make the process of creating digitalization to different purposes to make them faster. So, Marcus today will explain us what is about this initiative globally. And Marcus, please take over.
Gracias, Aldo. Buenos dias. Buenos dias. Bienvenidos. A very warm welcome here over from Europe to my little presentation. I hope you can hear me. If it should not work, please, gentlemen, ladies, give me a little help that I see if something should not work. So my title for my next minutes is Be the Clever Mouse and Not the Slow-Moving Elephant. So what do I have with me? A little agenda for you, ladies and gentlemen, automation solutions. And then I would like to go over to some application, what I think, where it is very easy to see how fast and how transparent digitalization could be. And then at the end, make a little summary.
Marcus, could you please highlight the presentation? Because we are seeing you bigger than the slides.
Okay. Thank you. Just highlight the presentation. Okay, is it now better?
Yep, now it's better.
That is. Okay, digitalization. Why do we do digitalization? Why is it necessary to think in digital steps for our future? I think it's important first, before we think about digitalization, that we need to create a scalable environment for it. That does mean that I have now a little issue. So, but we have to think about one sentence, ladies and gentlemen, which is not from me, which is not from us. It's from Peter F. Drucker. He was an economist in the last century who said a great sentence, a great phrase: you can't manage what you don't measure. And before we think about digitalization, we have to start where it matters. And gentlemen, digitalization means in 2025 that we are really diverse, that we think about the generation, which is maybe a big doubt, but that we all bring these different groups and folks together, that we keep it easy. And again, if digitalization is not easy, if we don't open our minds, we will not be able to get scalable, transparent, fast decision making. And this is what we did here in the PLC Next factory in Bad Vermont, or what you see on that slide here, quite in the middle above, is the All Electric Society Park, where we are really coupling sectors, different industries, different machines, where we are coupling buildings with factories and plants, and all between is digitalization, which is not important where we are and what we are. That does mean it has to work in factory, it has to run in the building, it has to run at a PV solar plant. This is digitalization where we see, and this is how and why we call it then now. If you would have to digitize your industry, your factories, your buildings, and always you need a different setting, a different tool, a different application. That would waste a lot of time, ladies and gentlemen. So that was our first major point that we said, wherever we are, for you, ladies and gentlemen, visualization has to have the same spirit, has to have the same ecosystem, which is a we and not an I. Visualization, data-driven decision making with the people together. And then we went to the next step, and this is a little bit of technical approach to show maybe some tech folks in the audience what we are doing. Well, this is not an advertisement today, but there's one product that we call PLC technology. It's our has the decision making, and it is not important what we are metering. And again, not what we are metering. It is possible to grow with the systems with third-party software, all within that ecosystem that we call the PLC-based technology. And I told you, ladies and gentlemen, that we walked the talk. We did it on our own, of course, in 2019. And well, we are an electronic goods user. You know, we have everything that you need for cabinets until DC goods for secure plants and factories. And one of our factories is right here where I am at the moment, what we call the PLC Next factory. And look how it was in 2019, quite the paper-driven factory. And today, we did a step further. We said, okay, we have a lot of legacy devices, machines, plants, and on top of that machine, we see a little box. That boxes, the two boxes, they have one big value. They don't touch an existing running system. That just means we do not have to be afraid of, only do we have the knowledge what is running into that asset, into that machine. And we were talking with the folks, with the operators and our factories, hey, what is important? Because we are not the domain expert. These guys working on the machines every day, 24 hours, seeing what is good, what is bad. That is the database for whatever we want to do in the future for AI or machine learning. So, and you see here a picture from our factory. You see here our data managers, our folks from the production. And we are using here now open systems, collaborative systems, and systems where it is not important what's the nature of it. And I just can say it again here, if you maybe have later big time, go to the internet, type in your browser, PLC Next Factory, and you can see what we are doing in detail, what is our mindset and how open we are due to that strategic approach. A little bit, you don't have to read all the fancy names, but this is what you see here, is using what you have. Don't be afraid how to get information from something, because with our toolboxes, we can get each signal, each data, each sender, whether it's a hard sensor or a 20 milliamp sensor or something using NoTech, we just can get it and then create a microservice architecture, ending up in open systems like a 3D visualization as the right on the slide. And we know machine learning for faster decisioning and on or off premise, and not nudging. Nudging, that's an English way, which is saying to nudge somebody. Somebody with a little kick to move right forward. Am I right? And this is what we did together with the operators in our factories, in our plants, in the buildings, because they know they are the domain experts for all what we are doing with our microservice architectures, all what we are doing for our faster decision making. What you see here now is just one example. It is an old asset, it's a selective soldering machine. But we said once, do not touch that machine because that was an old machine running for 20, 25 more years. And we said, okay, we have some utilities with that asset, with that machine. And we said, okay, we don't touch it. We use clamp-on devices like the Rogowski coils. We use clamp-on sensors to meter in that case the utility supply of the machine, the nitrogen. We say, by not touching the machine, we do not influence the CE or UL approvals. We need some, as I told you, toolboxes which are individual, which are certified, which are scalable. We call these boxes data collection boxes or metering boxes for each and every environment, whether it's a hazardous environment or it's just something that you can mount directly to a skills, to a machine. And then for me, because all the world is talking about more data and more data, more data is not the real answer to the future, because with more and more and more, you cannot handle all that information. It's like a social media thing which is going on at the moment. It's too much information. We are losing the right information for the right people in the right format. And see what we did. To have a more productive approach, a more sustainable approach with that machine, we only need 3 to 5%. Turn it around, ladies and gentlemen. That does mean at the same time that 95 to 97% of the data being used the years before were just a waste of time. Nobody would really need all that information, ladies and gentlemen. So we were just creating fancy dashboards, beautiful papers, but nobody for a faster decision making. And quite important, it is to have a bi-directional data handling, which does start on-premise at the edge. You don't have to be afraid to put everything from the very beginning into a cloud. No, we can start very easily on-premise. You don't have to be afraid again of putting the data somewhere, and it's quite easy to fairly compare the amount of toolboxes maybe what you need from us to your saved energy or to a more productive environment of these machines and skills. And behind all of that, I was using the name before, is our ecosystem. It's a new approach, which is a we, which is digitalization with the people, which is automation, which is modular, open, which is scalable. And every AI will die if it is not scalable. And the people do not understand why it is important for me. With that environment, which is a we, again, and not an I, we can make these decisions in real time if it is necessary. If not, you don't have to. If you are the next generation and want to play with JSON, Node-RED, Spark, what we call PLC next store, where you can get ready-to-use application software for your pumps, for your motors, for your machines, for your plant, or your entire factories. Yes, where should we go? And I guess the most important or the challenging aspect when we think about digitalization is not digitalization. It's the approach to find the right use case. Give the application a name, knowing what does it mean for me? Is it more the resource optimization? Is it more the efficiency approach? Or is it just to get faster decision? And to get a faster decision could be, it's in the same time important if you just have one metering point, one sensor, or you have 1,000 data points. Give your use case the right name, the right time, and the right format, then you can start. But first, again, start with what is really important for me. What does it mean to be fast? And to see what do I have? Then it's about collecting. How can I collect? And it's important that you choose a system where you can collect any signal. The processing, where can I process all that information on and off premise? I told you it should be both possible and the analyzing. Again, don't dream of AI, make it clear, make it easy, make it fast decision making, what we call then at the end machine learning as a Docker application again for your device. And being all said, I want to show you now again why it is important to be more a mouse and not an elephant. Oh, of course, you can't be an elephant. And believe me, I have nothing against elephants. But what is a mouse? A mouse is flexible, agile, and can work, especially in brownfield environments, to find the weak points in our utilities, in our wages, water, air, gas, electricity, and oil, steam, isn't it? And I have a fantastic or a favorite application, ladies and gentlemen, our three-phase asynchronous motors. Maybe you're in the food industry, in the chemical industry, in the automotive environment, in the beverage environment, in the glass industry, in cement industry, in the mining environment. You all have that big electrical motors, three-phase motors. And when you look at about some statistics, what I put on that slide, it is fantastic to see how much mass, what we call machine learning next. And it's really a next machine learning, which is easy. And you can decide where you want to start it. To give you an example, a little bit of technical layout here, and I guess it's easy to understand. Think about again about your three-phase asynchronous motors. You need the power, you need maybe the temperature, the vibration, maybe any other value, and you can start on premise. So that motor is maybe already communicating with your existing SCADA or control or DCS system. But on-premise, just right in between, we started our solution, and you see, we get the data, so metering, we collect the data, we start the processing using open apps, like you see here, like Telegraph, like Grafana. And this is nothing from us. We just make the connectivity possible. And this is what Phoenix is doing since over 100 years. We are creating the right information at the right time. And then you deploy your model. Then you get the information. Well, now, if I do nothing, something could happen. So the first anomaly is detected. You get the warning, and you can decide if you want to do something or not. It's quite easy. I know, ladies and gentlemen, in detail, it's a bit more. So, but what you see here, again, not about the technique, it's about make it easy, make digitalization and automation easy. And you do not have to program. It's a just configuration of a set of an application. So, Alvaro, before I come to the end, I would like to give you back the speech.
Okay. Yeah. I think we couldn't see the last picture about the application of the motor. Can you go back a little bit? There, this one. Okay, this one is the application that Marcus was speaking about. That in this case, this is an example to applying machine learning to check the health status for a three-phase asynchronous motor that with some kind of simple tools we can offer, we can do or we can detect in early stage on a failure. And as he showed before, the applications that we can find in the industry are multiple. So, well, of course, we can discuss this each other afterwards. But what we wanted to do with you guys this morning was to give you, you can go back to the end, or you can go to the end, Marcus, please. Is that you can remember something based on what we saw this morning about what we are doing to enabling this digital factory process, getting in mind some purposes: sustainability, efficiency, getting more competitive in the market. And I think that the ingredient here is the industry give us the needs, their pains, everything. We as a manufacturer create the ecosystem that Marcus showed us this morning with hardware, with software, with open system, with systems that can speak each other no matter which brand you're using. But there's one part missing. And I think that you, the Academy, can take an active part on it. Yesterday we was speaking about that. There's a professor here that is pretty, I can let you know some conversations we had, and you meet him afterwards, Marcus, that the industry needs fast solutions. The Academy has the minds, has the people, has more time to develop stuff. So our message is to invite you to join us with this Digital Factory Now initiative. And Marcus, you are about to telling us something new to show us regarding the new booklet for, do you have this available to show this? Or?
Yes, I have it available to show, which is brand new from the Hanover show, from the Hanover Master, which was happening last week. It will be soon available in Spanish as well. Here, just a small preview where we talk about data-driven decision making, focusing sustainability, but also as well efficiency, which at the end is the same. And the good thing is you hear a bit more in detail, 4 steps: metering, collecting, processing, and analyzing. But as well, at the end, you have real references, real world use cases where we've been from India over Germany to China and as well in Chile. Great project that we did in the last 2 years at Rigo Sorno, which I guess you know better than me, a big slaughterhouse company in Chile, with our utility metering and reporting approach. But not only that, as well, I can only invite you to have a look at our landing pages where we talk about more in detail about our approaches for digitalization and automation. You have the links in that PowerPoint. I guess either you will share to all the audience that slides. They are free. You can use them. And I say now from my end, muchas gracias.
Okay, well, thank you, Marcus, for joining us this morning. Of course, doing this kind of shows alive, probably the audio was not the best, but thank you, Marcus, for being us together with us today. Any information you would like to know about this? Well, you see here our landing page, our new booklet. I'm available to give you access to this information, or you can contact your people in your countries to do more knowledge in detail about what is Digital Factory Now. So I leave you invited to visit us in our booth to discuss some things you want to talk about this. Thank you very much, and please continue with this great Congress. Bye-bye.
Thank you. Ciao.
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 Wait a minute, please. We have questions this morning.
Oh.
Phoenix got that?
Perfect.
Maybe to Alvaro?
Yeah, if you have any questions, sorry for that.
No, don't worry, no problem. All's okay? Thanks so much,
Alles
Alvaro.
gut.
Yeah, alles gut. Dankeschön. Okay, Professor Langman, it's your turn, please. Yes, the presentation is okay. And
Yeah, good morning. Good morning, all. Today, my presentation is about artificial intelligence. But you know, the last big thing was Industry 4.0. But for the Industry 4.0, we had a clear objective to make the production better, to more efficiency, and so on. We had a lot of specialists with a good background, with knowledges, what to do. And also the equipment was well known. We had a lot of standards and norms for Industry 4.0. Now, and the next big thing is artificial intelligence, AI. But what do we have for AI? We have nothing. AI is a tool, no more. It's a powerful, very powerful tool, but we have no standards, we have no guidelines, we have no teaching and learning documents, we have no specialists in automation technology. No? We don't know the limits. We have no evaluation guidelines for AI. And so we need in the future a lot of investigations and research work to have this or to know better what we can do with AI as a tool. Because a tool has no objective. There's no. The question is, can we use GPT for programming with a PLC Next system? I will give a small introduction, some examples for PLC programming with AI, conclusions and future work. Okay, let's start with a question, what is ChatGPT? It's very interesting. ChatGPT is a voice assistant. It's a voice assistant. It's AI, but it's a voice assistant based on a large language model, LLM, developed by OpenAI, and it's based on the transformer architecture. GPT, generative, pre-trained transformer, and GPT uses deep learning for natural language processing, NLP. Here you can see the history. The first version was 2018. 2018, you can see 117 million parameters. One parameter is a combination from the weight and biases of a neural network. It means it's in comparison with a brain of a human being, is one parameter is one synapse. And you can see 2020, we have GPT-3, 175 billions of synapses. And 2023, GPT-4 with a better context processing and multimodal capabilities. For me, it was very interesting here, this point, GPT-4, more than 1 trillion synapses. The brain in a human being has at least 1 trillion synapses. And you can see this is it is a very fast development process. You will have every 2 months, you will have a new version. If you want to use it in a production area for a product, what do you think? What time do you need to realize a product with AI inside? maybe you need a half year. Maybe you want to sell this product also for 1 year or 2 years. But in this time, your AE is very old, because every 3 months, every 4 months, you will have the next generation of AEs. I don't know how we can make a solution in the future, but this is really a big problem. So we have here the current versions of ChatGPT. You can see May last year, GPT 4.0, December 01, January this year, 03 Mini, January 03 Mini High, and from February we have 4.5. Very fast. And here you can see a small description. The problem is development of new and powerful models in ever shorter time intervals. Yeah, objective in this small project is how can we use ChatGPT for generation of PLC programs, for development of a PLC program. And the second focus is the question of the extent to which ChatGPT can support the training process for learning PLC programming. Here you can see the investigation environment. We use ChatGPT 4.0, it is from last year. And for the program test, we use the EWA PLC Next technology board with a PLC Next engineer as a programming environment. All tests were conducted between October and December in the last year. And if a specific prompt is entered repeatedly after a longer time, some days, a different type of output or even a different solution may result. Due to the system's ability to learn identical answers to identical questions cannot be expected. So I have here three examples. You can see one example is the classical solution is a very simple example. You have 3 lamps and you have 3 switches. One switch is an opener, and you have to write a ladder diagram, a PLC program in ladder diagram syntax, and you have a description. You can see the description, and on the left side you can see the right program in PLC Next engineer, in LD, in ladder diagram, and on the right side you can see the assignment of a process, the input and output process variables. Very simple. Okay, the AI solution. You can see the prompt. The prompt, we extend the prompt a little. The corresponding PLC program is to be written in LD. We have to say what we want to have from the system. The variable nouns should be based on the syntax for Boolean variables specified in IEC 61131. Also, we have to say to AE what we want to have. And the feature shows the electrical wiring of a lighting control. I mean, the one component of a prompt was the text description, and the second component is this picture from this wiring of a control system was uploaded. The result, the result was wrong. Ladder diagram contains duplicate coils. But in a LD in a LD, never you will have duplicate coils. When we start with an additional prompt, what are the individual coils for in the ladder diagram? Why does each network contain 2 coils? Then, in this case, the result was a correct ladder diagram and explanation. This is the output. This was the output from the ChatGPT. And then you can take this code to be as the next engineer. You can test the system, and in this case, it was okay. Okay, it was a very, very simple example. Here's the second example, latching with and/or. I mean, here you can see you have a conductor is to be switched on and off using 2 push buttons. And push button S1 is normally open contact and switches the conductor on. And you have a self-holding contact of conductor key 1 and is connected in parallel to push button. The key 1 is connected to parallel to S1. And yeah, this figure shows the signal diagram for the conductors. You can see on the left side the self-holding state of key 1 is cancelled when S2 is activated. You can see the F function block FPS diagram in function blocks. And you can see the assignment of the input variables and the output variables. We have only one output. It's our conductor key 1. It's a classical solution. So for the AE solution, the prompt is the same. We extended also, you have to write a FBD program in and the variable names should be based also in the syntax for bool variables of IEC 61131. Result, ChatGPT is unable to generate a correct program based on the prompt. We have a problem to recognize that's a SR flip-flop. The GPT didn't know a flip-flop. It was a problem. The basic principles that the latch is a SR flip-flop is not understood. And for output, you can see this was the output. It's crazy. Eh? It is, and only after explaining that a latch with a parallel latching contact is essentially a SR flip-flop, it was a correct program output, but created in an unfinished graphical presentations. It was a result from for this example. Nevertheless, the example is also very simple. No? It's for each PLC programmer, it's basics. Okay, when we try to use a more complex example, you can see a sampling of a model car. You can see here we have a model car, and you have a gripper and an arm, and you can put you can assemble a substation with a chassis of a model car, and then the gripper can put the keros to the chassis. Here you can see on the left side the control program in a classical solution. We use in this case the SFC programming language. A long description. It was more than, I think, 2,000 or 3,000 cares. When we uploaded also the pictures, the schematic structure, all to the AI, What was the result? ChatGPT correctly identified the process variables from the extensive task. We ask different things. First, create tables for the input and output mapping of a process variable as well as a table of internal variables. Secondly, specify the required states for sequence control. And third, specify the transition conditions between the steps. And fourth, specify the content of the actions for the respective steps in ST language. For the first one, ChatGPT answered correctly. And ChatGPT also suggested meaningful process steps. These processing steps are not the same as in classical solutions, but it was meaningful process steps. Also, the transition conditions between the steps was correct. And SD code for the actions was also correct. After correction and syntactical conversion of a result into a PLC Next program, because the syntax was a little different, the assembly process essentially functions according to the task. Here you can see on the left side a part of a AI program. It means in this case it was very helpful, and it was very interesting that ChatGPT can take the pictures and the schematical structures and can recognize, we have input variables, output variables, I can create the conditions and so on. Yeah, some conclusions, maybe. If program code for specific technical languages is to be output as a result of a prompt, it is useful to pass essential information about the correct syntax to the ChatGPT. ChatGPT doesn't know the correct syntax. You have to tell ChatGPT, okay, I want to have this syntax, ST syntax or LD, or so on. With ChatGPT, the user must determine for himself whether the system can even deliver correct results in the given case. ChatGPT does not provide any information about its performance and scope of service. It's, I think it's a problem, especially for beginners with ChatGPT. You have to evaluate the answer. You have to know, could it be right or not? ChatGPT never will do it for you. Solutions that require specialized graphical languages should not be requested from ChatGPT. We have always problems with graphical outputs. In the last year, I checked now with a newest version, it is quite better than in the last year. Now you can create also a good graphic, a PNG graphic, and it will be from generation to generation or from version to version, it will be better and better. But up to now, it's better to request ST language from as a code, textual code. ChatGPT also provides helpful control, results, and explanations for more extensive tasks. I can see here 3,200 cares. You can also use, it's also good. And GPT currently appears to have only rudimentary knowledge of PLC technology and relies primarily on the correctness and completeness of a task description. Of course, you can create your own model. I mean, in ChatGPT, you can create your own model, and you can input in this model all this information from a book or from a PLC textbook or so on. And then this model could be better than the common model from ChatGPT, but up to now, it is hard to test because you need a number of prompts, questions. You have to compare it with a common model, public in the internet, and so on. Here you can see an overview. We test up to now. We tested 10 programming tasks for BLC Next. You can in the table see the task recognizing of a function of a it's ST program. Yeah, we use ST. It was a theoretical task. It was some statements, and the question was to create or to describe the functionality of this code. Describe the functionality. And the code was a toggle flip-flop. I mean, divide by two, no? Binary divider. Here was a problem that the jump command was unknown by ChatGPT. Then the lighting control with switches, latching with and/or, control of a three-phase motor, binary number. It was very good. Analysis of a signal curve on a flip-flop. It was also good. Lighting control with buttons. It was a problem. Control of a punching machine. More or less it was good. Semi-automatic transport system. Here it was a problem. ChatGPT didn't know the cyclic operations in a BLC. And chassis assembly, it was also more or less good. At the end, you can see 20% was okay. We could use this program. 30% more or less okay. And 50% not applicable. But I have to say, 50% not applicable. We used only maximum 3 additional prompts, or 2 or 3 additional prompts. Of course, you can discuss with ChatGPT. You can make 1 prompt, then you can test this program. Oh, no, it's not working. Where's the problem? This process signal is true and should be false. You can tell this in a new prompt to ChatGPT. Oh, correct the program. I have an error. Okay, you will get a new code. You can test this new code. It's working. It's not working. Again, and so you can step by step create, by help of ChatGPT, the programming code. It is very, very interesting, and it's really so you can, at the end, if you have enough prompts, I think you will have always a right program. But maybe in some kinds you need 10, 15, 20 or more prompts. It is a discussion. So some summary conclusions. We had in total for all 10 tasks examined, we have in total 30 conclusions were obtained. Generation of PLC programs, ChatGPT currently has only rudimentary knowledge of PLC technology. But I think it is, in general, it's not a problem. It's only a problem of a knowledge base. And relies primarily on the correctness and completeness of a task description, and so the prompt is very important, of course. PLC programs in FPS, SFC, and partly also LD cannot currently be expected as output, I mean with graphical outputs. ChatGPT also correctly recognizes extensive tasks, text, descriptions, and schematic images. Using for PLC training is also very interesting. Without sufficient knowledge of control engineering, ChatGPT is difficult to use as a learning tool. I mean for beginners and for students. The learner should be able to evaluate the results. What is my hypothesis? If ChatGPT does not produce a meaningful result for a task, an averagely intelligent learner will also not produce a result. It is very interesting. Maybe you can use ChatGPT to evaluate your questions in an exam. Because you have, if ChatGPT can give you a right answer, also you will have a problem with students. Okay, ChatGPT could be used to check the comprehensibility of a task for learners. Maybe, maybe not. Maybe we need more investigations. It is extremely disadvantageous for inexperienced learners. In every result, ChatGPT claims by default that the task in the prompt has been completed correctly. Sometimes I think ChatGPT is a marketing assistant. You will get a prompt, you will get a code, and ChatGPT at first is writing, I will give you now a code, it's 100% correct. You can test it. The code is wrong. You give an additional prompt to ChatGPT. You will get a new code. Oh, sorry. But now I tested this program. It's 100% correct. You can test. You have an error. I mean, you have always such marketing statements as a politics. Eh? You can ask. You will get always an answer. Never you will get the answer, I don't know the answer. And so it's really a problem for the beginners. Yeah. And this is the biggest problem due to the rapid pace of development, the rapid emergency of new models, and the learning capabilities of the models themselves. It's virtually impossible to generalize the experience gained by ChatGPT in a specific subject area and transfer it to the future work. This is the problem. I can tell you today some experience and conclusions, maybe in a half year, you will have completely different conclusions. And each model provides different answers, but how is a user supposed to assess the quality of a model? There are no education certificates for AI models. You have a certificate for an engineer, for a specialist, for a student, but no certificates for AI. Okay, future work. Now we are working on a training document together with the Fraunhofer Institute, IKS in Munich. We plan to develop a training series on PLC in engineering, not only programming, also engineering, with AI in this next year. The training series will consist of learning materials and video tutorials. And we are working on a technical book. Karl-Hanser Verlag is currently producing a textbook entitled Fundamentals of PLC Programming, Classical, according to IEC, with AI and from the cloud. Release will be early in the next year. Okay, thank you very much. If you have questions, please.
Thank you.
By the way, it's the picture is from Chile. It's in Atacama.
Thank you. Thank you, Professor Langman. Questions? I have questions. Really interesting presentation. And really good photo for the north of Chile. Yeah, also. So, no questions? Thank you, Professor Langman. And then you continue to the Arauco company. Christian and Oscar, please.
Hello. Okay, good morning, everybody. We are very pleased to be here. So thank you so much, Manuel and Phoenix Contact guys, for the invitation. We're very pleased and proud to be here representing Arauco. So today we're going to be talking about data and what are the new challenges that we need to face with this data and how a right piece of hardware can help us to solve these kind of issues. So my name is Christian Vasquez. I'm an electronic engineer. I work as a senior automation engineer for technical management area for Arauco company. And with me is Oscar Cifuentes. He's a chemical engineer and he works as a data scientist for the same area and company. Our presentation is called PLC Next as interface for machine learning models in industrial applications. Okay, so first thing first, what is Arauco? Arauco is a forest company that was born about 50 years ago in the south of Chile. The main purpose of this company is to produce quality products, quality wood products, of course, and using renewable resources and maintaining the sustainability in our process and reducing the environmental impact as well as we try to optimize the process as much as we can. In Arauco we have three business lines, mainly three business lines. One line is the wood product mills in which we produce wood products like MDF, plywood, and so on. And for that we use pine wood. And the other business line in which we are focused working is the pulp mills. Okay, so in the pulp mills, of course we produce pulp, and that pulp is used to produce paper products, tissue, and also textile products. And the third business line that we have is the such as, for instance, black liquor. We can burn that black liquor and we produce heat. With that heat, we produce steam. We work in the technical management area for Arauco, and our mail tons and tons of data each second. So we use that data in order to analyze it, in order to propose new control strategies, all of that in order to optimize the process. So today, like I said, we will be talking about data and the challenge that we need to face with those data. So, Oscar, please.
Thank you, Christian. So as a data scientist, we analyze all kinds of data: business KPIs, security and environmental data, maintenance data, lab reports, productions KPI. But if we think about it in an industrial process where we can do live trends and data analysis. To understand and control our process, we need reliable process data and use this data to meet business KPIs. But data is not always reliable. How so? For instance, here we have historical data of a sensor for a process variable with a usual behavior. It's a good representation of what is happening in my process, and I can control my process according to this data. But depending of the process nature, this sensor is susceptible to fail, like the screen. So in this case, showing values that are not representative of my real process behavior. So now I do not know what is happening to my process and what I can do as a data scientist. I can analyze data. So we can go and see other process data that is related to my faulty sensor. And we can see that this data has similar behavior to my failed sensor. And this data does have information at the time where my real sensor is failing. So if we take the data from a period of time where my sensor is working properly and compare it with my other process data, we can find mathematical correlations between the sensors of my faulty sensor in real time. So what we have achieved with this virtual sensor or sub-sensor. Now we have a decent approximation and have information of my process, but I can use this data in our control system. And now, if we zoom in our model and compare this model with my real sensor, we can see that we have a decent approximation of my data, but it has some rough edges. How so? We can see, but can we improve it? So we can, for instance, instead of use simple models in our data historian, we can use more advanced tools like Python and machine learning libraries and have a better approximation of the real data. But this is kind of meaningless if we still only have the data in our data historian. The real value for us is to send this model to the DCS, to the control system, and do proper process control with the virtual sensor. And in this point of time, we didn't have any means to do that. So that's when I came to Christian with the question that how can we send the results of a machine learning model in real time to use them in our control systems?
Okay, so for me, the problem was really clear. Okay, we need to put this valuable information into the DCS system. Why is so important to bring the output of this machine learning model into the DCS system? Because we need to use this information. The operator needs to see this information, maybe to take a more or a better decision over the process by using these results, or even more, we can use these results in order to make a new control loop using any technique for control like a PID or fuzzy logic or anything. So that's the importance to bring this information into the DCS controllers. So how can we do this? In the schematic there, I have a typical network architecture that we can see in any mill. In the bottom, we have the field instruments, such as DCS controllers in the mill are connected somehow. And after that, we have the engineer and operation stations. So in there, the operators can control the process, and as well, the data flows forward and backward. But how we can get those data in order to make our machine learning models? Like you can see there is an IT network which is getting those data from the field instruments, but in this case, the data flows only goes forward. We cannot write backward to the system by using that connection. That's not allowed because of the cybersecurity policies. Technically, you can do it, but it's not allowed. So all those data goes to the data logger, any data logger or historians, and Oscar and I, we can access those data loggers to download data or even to work with real-time data in our servers in order to make these machine learning models. But here we found the brick wall, how we can put these results into the DCS controllers. Okay, so can we run these machine learning models directly inside the DCS controllers? Right now, we cannot because the machine learning models are based on Python files, so the DCS controllers don't have the capacity to run these Python files. Okay, so let's try to find a piece of hardware that we can use it like a PC for running these Python files, but also to have the capacity to communicate this system with the DCS controllers. And that is where we find out PLC EPC 1522 from Phoenix Contact. That's a PLC, but it's also a kind of PC, right? It's running, we can run there the PLC Next Engineer software, and also it is running Linux operating system inside of it. So, okay, we can run our machine learning models inside this PLC, and also we can communicate this information through a Modbus communication with the DCS controllers. And as well, we can put a local engineering station to communicate with the PLC, and there we have our solution to run the models and to put this information back to the DCS controller so the operator can have the information there, or maybe we can make a new control loop inside the DCS. So that's our solution that we found, and now here I want to talk a little bit how I did or how I configured the internal architecture for the PLC. So in the right hand, I have the DCS system, right? We have the output variables from the DCS, which are the input variables in the PLC. And we have the input variables in the DCS, which are the output variables from the machine learning model that we want to have inside the system. The communication there is being done by a Modbus communication, TCP/IP. So we fixed that. We solved that issue. Now, in the PLC side, I divided into two layers: the Linux system, where I'm running the Python files, and the PLC Next Engineer software, where I had to use that because I needed to do some fixes inside the PLC side. So the model that Oscar was working with, he has to use some data, but not in real time. He told me, hey, Christian, I need to use data from 1 hour ago, from 2 hours ago, and from 8 hours ago. Okay, how can we fix that? We can use a vector to storage data using a trigger by time. So I can trigger any hour in order to save those data in the properly timestamp. Okay, so that's fixed. Then how can I communicate the Python files with the PLC side? And here is a really nice feature that this PLC has, that we can start up an OPC UA server inside the PLC, so we can communicate the Python files in the Linux system and the PLC side. All right, so that's solved as well. And in the Linux side, in the Python side, the first thing that I had is a really big Python code. It was only one Python code, and it was really big. So I figured out that in order to make this scalable and easy to use, I had to divide this Python file in little bits and little piece of software. So why I had to use that, or why I had to do it in that way? Because I know that we are not only making one machine learning model, we will be making a lot of them. So I had to use it scalable and easy to use. So I know what piece of software I need to edit in order to make any other models that we need to implement in the system. So in the Linux side, I had to use two external software. One is called PuTTY, and the other one is called WinSCP. One is for triggering manually the main code, which is there represented, and the other one is only for copy and paste the files inside the PLC. So that is the solution that we implement to put this information inside the DCS side.
Thank you, Christian. So now we have the PLC that allow us to send machine learning models to the control system. So we built a new model using the same variables as our previous model, but this time using a machine learning model with Python and machine learning libraries. And now we can see how this new model behaves compared with our previous model. So to remind you, here we have the linear model with all his issues. And now we replace it with the machine learning model. And now we can see that it has a far better approximation of our real sensor. And now we are able to send it to our DCS and proceed to control our process, even if our real sensor fails. It's good enough for process control now.
Okay, so what's next? We were using this external software, the PuTTY system and the WinSCP, but the PLC has another kind of solution that we can implement, and we need to explore the container solution in order to run this model as an external app inside the PLC. So it will be more easy to use and even more scalable. And some final thoughts about the potential EPC usage. This is a kind of dream that I have, is that we can implement, we can use this EPC to implement control expert solutions, such as develop MPC, fuses, libraries, and use the intuitive HMI to adjust online parameters. Also, we can use this system in order to calculate optimal tuning parameters for PIDs inside the DCS, a kind of auto-tuning loops. And for me, I think the sky is the limit, right? So your imagination is the limit in using this kind of
Questions for the interesting presentation?
Congrats for your presentation, and that your solution is a very interesting solution and applicability for industry. Maybe I missed the part where you explained it, but what kind of fault sensor is that? Maybe bias problem, gain problem, very specific problem, because the sensor fault the signal. The sensor fault must be very specific behavior.
So in this case, we use an example, a real problem that we have in the middle. The reason that make this sensor fail is like the process nature. It's a very specific part of the process where the sensor kind of gets dirty, just fails constantly. So it's difficult to kind of stop the area and change the sensor or make a way to the sensor to not get dirty, to not to fail. So it's kind of a problem we can repair unless we stop the mill. So that's kind of not a possibility. So that is where we think about how we can make a solution without with the data we have. So there, the idea of make a sub-sensor comes around for this kind of sensors or problems.
Other questions, maybe? Are you sure? No question. So thank you, Alvaro, thank you, Professor Langman, Christian, Oscar, Phoenix Contact, Arauco Company. Thanks so much. And next, we have a coffee break. But and I invite to you, and greet and meet with the EduNet for Phoenix content, just in the Phoenix content stand in outside. So that's it. Thanks so much.
Thank you.